Chapter 2.2, Solving Absolute Value Equations. Essential question, how can you solve an absolute value equation? Well, the answer to the question is 1, graphically, 2, algebraically. We're going to be examining both of those possibilities today. Explore solving absolute value equations graphically. So we're going to build here upon what we did in section 2.1, which is graphing absolute value equations. And here we go. A, solve the equation 2 times quantity f's value of x minus 5 minus 4 equals 2. Plot the function fx equals 2 times absolute value of quantity x minus 5 minus 4 on the grid. So we're going to graph this thing first. And the standard form of absolute value equation is fx equals a times absolute value of quantity x minus h plus k. And so our vertex is the coordinate pair h comma k. And so in this instance, for this absolute value equation, we have h is equal to 5 and k is equal to 4, or negative 4. And so our vertex is going to be the coordinate pair 5 comma negative 4. And so we're going to go put that here. See the one like 2, like 5, 5 to the right, 4 down. We mark that here. We put 5 comma negative 4. And then a is equal to 2. Right, we have 2 out front. So we go up 2 over 1. So really it's the slope, right? Up 2 over 1. Up 2 over 1. So we're going to be looking like this to the right. And it's hard to do this. It's hard to get this free-handed here. Okay, on the left side, we're up 2, but over 1 to the left. So we have symmetry. So it's going to look like this. Okay, and secondly, we're going to plot the function g of x equals 2. So g of x equals 2. Okay, so g of x is equal to 2. F of x is equal to 2 times absolute value of quantity x minus 5 minus 4, and it says mark the points where the graphs intersect. So our intersection points are here at the coordinate pair 2 comma 2 and at 8 comma 2. And so the solutions to this equation are x equals 2 and x equals 8. So let's be the x value where these graphs intersect. Now I'm going to quickly go to graphing calculator. And here's our TI-84 CE graphing calculator. We're going to put in our absolute value equation 2 times second catalog, enter x minus 5, and we're going to have minus 4, so we graph that. So that's what we have, and then we graph our second function, which is y equals 2. So we see the intersection points. We can find them by second trace 5, enter, 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 and we get the point 2 comma 2, just like we had graphing manually. And then to find our other intersection on the right, we go to second trace 5, we have a cursor over here, so what we're going to do is just scroll over closer to the other intersection point. When we do that, we press enter, 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 and it gives us the coordinate pair 8, 2. So the same solution as earlier. Let's move on. Reflect. Why might you expect most absolute value equations to have 2 solutions? Why not 3 or 4? Well, the reason is because the horizontal line, or any line, the line can intersect the graph of an absolute, brief absolute value equation at most twice or 2 times. And then we have reflection 2. Is it possible for an absolute value equation to have no solutions? One solution. If so, what would each look like graphically? So the answer to that question is yes, and I will show you what they look like. So what I'm going to do is create 2 coordinate grids. We have x, y here. I'm going to do this thing over here. Right. X, y. Okay. In the first instance, if we have an absolute value, graph an absolute value function, and we have a horizontal line that does not touch the graph of the absolute value function, that would be an example of no solutions. No solutions. Next, here we have an absolute value function. We have a horizontal line that is just like this. Touches right here. This example here would be one of 1 solution. So graphically, that's what no solutions and 1 solution would look like. Next, explain 1, solving absolute value equations algebraically. So now we're going to get into just the algebra, basic algebra skills will be involved. If absolute value of x equals a, and what you're doing is you're isolating an absolute value expression on one side of the equation. If absolute value of x equals a, where a is a positive number, then x equals a or x equals negative a, and then we solve for a. Let's go about this. Here's an example 1 worked out for us. We have absolute value of 3x plus 2 equals 8. We subtract 2 from both sides, we get absolute value of 3x equals 6. And so what that does, it gives us 3x equals 6 or 3x equals negative 6. And solving each equation respectively, we get x equals 2 and x equals negative 2. So we can mark those solutions on a number line. Okay. 2, 2. Okay, now we have B, and just kind of follow along while I do this, or you can work ahead if you'd like. So here, if we have our equation, we add 2 to both sides. The equation, to get rid of this negative 2, we get equal to 21 on the right side. Next, divide both sides by 3. We divide both sides by 3. We get, on the right side, 21 divided by 3, which is 7. And now we have our absolute value expression isolated, so we have 4x minus 5 equals 7, or 4x minus 5 equals negative 7. And then we add 5 to all sides. So on the left equation, we get 4x equals 7 plus 5, which equals 12. On the right equation, we get 4x equals negative 7 plus 5 equals negative 2. And next, we solve for x. We can divide by 4. We divide by 4, we get x equals 3. And so here we have our solution down here on the number line, x equals 3. And for the other equation, we divide by also 4. We get x equals negative 2 over 4, which simplifies to negative 1/2. So this is our second solution, negative 1/2. Now, your turn. I invite the viewer to go ahead and work out number 3. Then, after having paused the video, just play ahead and see if you got it right. Okay, we have 1/2 the absolute value of quantity x plus 2 equals 10. So we can get rid of this 1/2 by multiplying 1/2 by 2. And we would do similarly on the right side of the equation. So we get absolute value of quantity x plus 2 is equal to 20. And so now we have since we have our right side is a positive number, we have the equations x plus 2 is equal to 20, and x plus 2 is equal to negative 20. And we solve both equations by subtracting 2. We get x equals 18. That's one of our solutions. So we can mark this on our number line. And then our other equation, we subtract 2. We get x equals negative 22. So there it is, negative 22. Now for number 4, I invite the viewer again to pause the video, work it out, then play it in to see if you got it right. Okay, on this equation, if we subtract 5 from both sides of the equation, we get negative 2 times absolute value of quantity 3x minus 6 is equal to 1 minus 4, 1 minus 5, which is negative 4. Now if we divide both sides of this equation by negative 2, we get absolute value of quantity 3x minus 6 is equal to 2. And since we have isolated the absolute value expression on the left side, and that is equal to a positive number on the right side, we have two possibilities. We have 3x minus 6 is equal to 2, and also we have 3x minus 6 is equal to negative 2. And now if we can just solve, we add 6 to both sides of this equation on the left. We get 3x is equal to 8. Divide by 3. We get x is equal to 8/3. And on this number line, I think we're going by 2/3, 4/3, 6/3, 8/3. So 8/3 is going to show up right here. Okay, next, this other equation, we add 6 to both sides of the equation. We get 3x is equal to 4. Divided by 3. We get x is equal to 4/3. And then on the number line, this is where it is located, 4/3. So that's that. Next, explain two absolute value equations with fewer than 2 solutions. Okay, we've seen that we can have 2 solutions. And then we have the second sentence. When the absolute value is equal to 0, there is a single solution. Okay. When the absolute value expression is equal to a negative number, there is no solution. And we demonstrated that graphically when we did reflect 2, what that showed what that looked like graphically. Let's go work out some problems. Here we have an example 2a. We subtract, so we have this equation here, subtract 2, we get this, we divide by -5, we get the absolute value of quantity x plus 1 equals -2. We have no solution. Just to remind ourselves of what that looks like, we have, very pretty here, but we have absolute value of quantity x plus 1, which is going to have its vertex here at x equals -1, so it will come like this. So that's what our graph, our absolute value function is going to look like. And then we have our second graph, what's on the right, we have y is equal to 2, or -2. We have no intersection, and so therefore no solution. Next, we have an example of when we add 3 to both sides of this equation here. On the right side, we get a -3 plus 3, or 0. And continuing to solve, if we multiply both sides by 5/3, we get well, I'll just put what we have here. We get on the right side 5/3 times 0 is still 0. And then we have 2x minus 4 equals 0. We add 4 to both sides, we get 2x is equal to 4. And now dividing by 2, we get x is equal to 2. One solution. Next, problem 5, I invite the viewer to pause the video, work that out, and then play ahead and see if you got it right. Okay, number 5, we're going to first subtract 7 from both sides of the equation. So we get 3 times absolute value of quantity 1/2 x plus 5 is equal to -2. And then if we divide by 3, we get absolute value of quantity 1/2 x plus 5 is equal to -2/3. Now, is it going to be possible for the absolute value of anything to equal -2/3 or any negative number? No. So we will say for this particular equation, there will be no solution. Again, the technique is to isolate our absolute value expression by itself. Once we do that, we see what's on the right side. If we have a negative number, no solution. For number 6, I invite you to pause the video, work out the problem, and play ahead and see if you got it right. Okay, from this one on the right, we subtract 7 from both sides of the equation. We get 9 times 24/3 x minus 2 is equal to 0. And then dividing by 9, we get absolute value of 24/3 x minus 2 is equal to 0. And now we can just go outside of the, right, we have 0, so we just have the equation 4/3 x minus 2 is equal to 0. We add 2 to both sides of this equation. We get 4/3 x equals 2. And now if we multiply both sides by the reciprocal of 4/3, which is 3/4, we're going to have x is equal to, I'm going to put aside here 2 times 3/4 equals 2 times 3 is 6, divided by 4, which simplifies to 3/2. So we have 3 halves for our answer here, one solution. Okay, so that's going to be it. I hope this has been helpful to you. Again, to summarize, We have possibility of 2 solutions, no solutions, or 1 solution. Good luck, and thanks for viewing.